Chuck.
Hey, Neil.
We got another explainer video to do.
I do enjoy the explainers.
You like them? That's very nice.
I do, because I learn things.
Okay, that's good. Today's topic.
What is it? Yes.
Big numbers.
Okay.
All right, let's work our way there. Okay, because I don't think people appreciate how big astronomically large numbers are. Okay, of course, astronomical as an adjective is reserved for big things and big uncountable quantities. Okay,
right.
There's a reason for that, and I want to elucidate this for you. First, we have to introduce exponential notation.
Okay.
Okay, so that's the number 10 raised to a power.
Right.
Right. So 10 to the third power is 10 times 10 times 10.
Right.
Which is 1,000.
Right.
So 10 to the third power is 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. 10 to the sixth power, it's a 1 with 6 zeros. That's a million.
Million.
Okay.
Right.
Are we together?
We're good.
Okay.
Yes. These are all the dream numbers of my bank account. So I have no problem relating to this.
All right. So the number 1,000 is pretty familiar to us all. The populations of most cities is numbered in the thousands. 10,000, 100,000, 500,000, this sort of thing. Let's go up by another factor of 1,000. So 1,000 times 1,000. Now we're at 10 to the sixth power. That's a million.
Right.
The largest cities in the world are measured in millions. Okay, right. I'm native of New York City. We're 8.5 million or something, such as that today. Let's go up by another factor of 1,000. So we go from 1,000 times 1,000 gets to a million.
Right.
Times another 1,000, we add another 3 zeros. We get to what?
A billion.
A billion.
So 1,000 million. We have 1,000 million, and that gives us a billion.
That gives you a billion. That's correct. And so that's Carl Sagan's favorite number. Okay,
billions.
Let's say billions. That's his favorite number. It shows up a lot in astronomy. Okay,
right.
There are between 2 and 400 billion stars in our galaxy. There might be as many as 100 billion galaxies in the universe. So that billion shows up a lot. Okay, well, let's try to further understand this. Okay, so how much money does Jeff Bezos have? What's he worth?
I think he's worth 80-something billion.
So let's round that to 100 billion, okay? So now, Here we go. Suppose I had 100 billion $1 bills.
All right.
Okay? And
I would be your friend for life.
So what can I do with 100 billion dollar bills? Well, I can take them and put them end to end, and I can go around the Earth 200 times.
Wow.
Okay?
That's a lot.
200 times.
Damn.
Okay, so now I'm going to put them vertically and see how high they go. Well, with what's left over after you went around the world 200 times, you can go vertically to the moon and back 10 times.
Wait a minute. That's in addition to going around 2 times.
No, 200 times.
Wait, you are going around the Earth 200 times.
Yes.
And then with the money left over.
Now you stack them
now
vertically
you can go
to the moon and back 10 times.
And back.
Correct.
10 times.
Correct.
Oh, that's insane.
Correct.
So my mattress money got me to the moon and back. That's the leftover cash.
Leftover cash. Other things. McDonald's used to keep track of how many hamburgers they sold. Do you remember this?
Yes.
If old timers remember.
1 billion served.
Up to 12 billion, 30 billion, 50. Then they just gave up, and you know what they say now? Billions and billions.
Billions and billions. Billions and billions.
Okay, so let's go up by another factor of 1,000. From a billion, which is 9 zeros, to now we go to 12 zeros. So billion, we have by. What would come after by?
But try. So trillion.
Trillion. So 10 to the 12th power is a trillion. Okay? About 1 trillion seconds have passed since cave dwellers painted on cave walls. Okay, here's why that's significant. Because you can actually count to 1 billion in your lifetime. And I celebrated my billionth second. I don't know if you did, but I celebrated my billionth. I don't know where you were.
Yeah, I don't know where I was either. I'll tell you this much: I missed it like that.
So you live your billionth second between your 31st year and your 32nd year of life. So I counted that out, and I had a real fast little sip of champagne, and that was my billionth second. So if you counted one number per second for every second you're alive, and don't sleep, and you can do it in 31 years. So how long will it take to count to a trillion?
Let's see. You need another 1,000.
It's 1,000 times that.
Not right. You need another 1,000 on top of that. So you got 1,000 times. So you're not gonna make it.
So you need 1,000 times 31 years to get there. How long is that? 31,000 years.
1,000. Yeah. There you go.
So if you want to give a kid a task because they're your kids, say,
I'm bored.
Count to a trillion.
Count to a trillion. There you go. And better yet, just make it 1 billion and see them and keep them going for 30 years.
Keep them going.
I'm so bored. Count to 1 billion.
So let's go up another factor of 1,000. So we go from billion, trillion. That's 12 zeros. So what would be the next number if you're keeping in the
quadrillion?
Quadrillion. And that has 9, 12, 15 zeros. This
is inconceivable.
I'm getting there. You don't know inconceivable yet. So 15 zeros. That's 1,000 times bigger than a trillion.
Okay.
Okay? A quadrillion, about 100 quadrillion, I calculated this, is the estimated number of sounds and words ever uttered by all humans who have ever lived.
Say that again, because that was a weird thing you just said.
Okay.
A quadrillion.
About 100 quadrillion.
About 100 quadrillion.
Is about the estimated number of sounds and words ever uttered by all humans who have ever lived.
That doesn't include flatulence, though.
And I had to have a separate term for congressional filibusters. They're in there too. So you want to get a sense of the scale of these numbers. I'm just putting it in context here in a cosmic perspective. Let's go up by another factor of 1,000. So we now have a number 1,000 times bigger than all the words ever uttered. So we went from trillion, billion, trillion, quadrillion, quintillion. Quintillion. So that's a 1 with 18 zeros. Okay? That's about the number of grains of sand on an average beach.
Oh, just one beach. Wow.
Just one beach. Just one. Well, just next time you go to a beach, just pick up a handful of sand and just look at it.
Yeah.
And then the sand is deep and it goes into the water a bit and it comes out and it's wide. So you do the volumes, you figure that out. So that's how you get a quintillion grains of sand on an average beach. Okay, but we're not done. I'm not done with you, Chuck. Okay.
Listen.
Can you handle the truth? Can you handle it?
I don't even know. I can't. I'm going to tell you the truth. Go ahead. Okay.
And keep in mind, we left Jeff Bezos long ago in this.
Right.
What we're doing here.
I'm telling you, like, this guy's broke as far as I'm concerned. I wouldn't even stop to rob him on the street. You know what I mean? It's like, Dad.
Let's go now 1,000 times bigger than a quintillion. Okay, so quintillion was 10 to the 18th power, 1 with 18 zeros. Now we're talking about 1 with 21 zeros. Okay,
21 zeros.
That has a name. Next up, sextillion.
Sextillion.
1 with 21 zeros. That is the estimated number of stars in the universe.
A sextillion.
Yes.
Say yes.
So that's 1,000 times larger than the number of grains of sand on a beach. Which is itself 1,000 times larger than all the sounds and words ever uttered. Actually, it's about 10 times larger than the sounds and words ever uttered by all humans who have ever lived. You can take that all the way down. So these are factors larger, not just additive increments, but factors increments. But let's keep going. I'm not done with you. 10 to the 23rd power. You met that number in your chemistry class in high school. 6.02 times 10 to the 23rd power. That's a mole in chemistry. Okay, and a mole is how many particles of a substance occupy a specified mass of that substance. Okay,
Gotcha.
a mole.
A mole.
Okay, and so there are vessels that contain moles of things, 10 to the 23rd molecules. So here you go. You ready?
Go
Do you realize there are more molecules of water in a glass of water than there are glasses of water in all the world's oceans?
There are more molecules of water in a glass of water than there are glasses of water in the entire volume of water in the world.
Correct. Okay.
Ugh, you know what? I'm going to drink to that.
Okay, so wait. Not only that, there are more molecules of air in a single breath of air than there are breaths of air in all the world's atmosphere.
Wow.
Okay, so what this means, that's not just a fun fact. What this means is when I drink a glass of water, and then it comes out of me 7 different ways, okay? I can sweat it, I can spit it,
urine,
pee,
well,
all of this. It goes back into the environment.
Okay, this has gotten really disgusting.
There are enough molecules that I have just expelled to repopulate all the world's water supply with some of the molecules that were in the glass that I just drank.
So here's what we've learned, people. When you drink a glass of water, you're drinking Neil deGrasse Tyson spit.
No, given enough time, it has to remix into the world.
Yes.
So that takes time. So if you can get a character from long enough ago, whoever your hero is it Socrates? Is it Joan of Arc? Is it Jesus? Just go far enough back in time.
At some point, there's a little bit of them in you.
Correct. In the glass of water you drink, there is water molecules that pass through the kidneys of Jesus. There are air molecules that were breathed by Genghis Khan. And so in that way, we are deeply connected in the fluids we consume and in the air we breathe.
That is so cool. That is one of the coolest facts we have ever divulged on this show.
And you can get that with 10 to the 23 molecules scattered back into the atmosphere or into the waters of the world.
It's all about a mole. Now, how do we take that and find out how we recycle Jeff Bezos' money into my bank account?